Hi friends, welcome back. Naji here. In this video, we will be discussing on a new topic, that is Amazon S3 vectors. First, we can see what AWS says about S3 vectors. So they are saying that Amazon S3 vectors is the first cloud object store with native support to store and query vectors, delivering purpose-built, cost-optimized vector storage for AI agents. So one of the key advantages is the cost. Okay. So if what they are saying is that if you use the vector storage or S3 vector storage, it will reduce our cost by 90%. So in this video, the goal is we will be creating a Amazon S3 vector and we will be using the Boto3 package to upload some data to vector storage, and we will try to do some kind of a similarity search with respect to S3 vectors. For that, first what we can do, okay, first we can create a new user. So let me go and create a new user. I can create a user called YouTube1. Let me click on this, and I can attach some policies. So I am going to give administrator access for this studio, and also I am going to give S3 full access. Okay. So these are the two access I am going to give. So let me create the user. So the user creation is in progress. Okay. Now let us go and view the user. Here we can see the user YouTube1 is there. Now go and create the security credential for this particular user, and I can click on create user. Let us click on others, next, create. Okay, now we will have the secret key and the access key. Okay, so we have our user is ready. Now go and click on the S3 bucket. So I am in the menu. Let us click on the S3 bucket. Okay, in the Amazon S3, if you see here, we can see a vector buckets. Let us click on this, create bucket. I am going to give YouTube1, create. Okay, so we have successfully created a vector bucket, that is the YouTube1. Now we can go to our Visual Studio Code. So I am in Visual Studio Code. So we need to install few packages. We need to the Boto3, HuggingFace and sentence transform is also needed, and ensure that you are using the latest Boto3 packages. Okay, so if not, just please do uninstall and just run the installation again. So similar to that, in case of NumPy, you have to ensure that you are using the NumPy version less than 2. So if not, you will be getting an error. So in that case, just go and what we call uninstall it and uninstall the existing package, then install it again. Okay, and yeah, so that's about the installation part. Now we can import Boto3. I can create a client. So here I can use client.boto3.client. I am going to use the S3 vectors, and I can set my region underscore name. So this is my default region, US East 1, and now let us put our AWS access key here. AC access key ID I can give here, and I can give AWS secret ACCESS secret key here. Okay, so I am giving my AWS access key ID and AWS secret key. Okay, let us copy from my screen. What is the key? This is my key. Let me copy this, paste it here, and copy this and paste it here. Okay, so the execution is progress. Now we have created a client. Now we can next step is we can create a sentence transformer model, or a what we call the embedding model. So here we are going to use HuggingFace embedding model. So specifically we will be using this particular model. Okay, so if you look on this, we will be using the sentence transformer all mini LM L6V2 is the embedding model that we are going to use. Okay, and it has a dimension, and its dimension is 384 is the dimension. Okay, so let's, using that I can come and create a model here. So let me create a model. I am going to create a sentence transformer model. Before that, let me import that one from sentence transformer. I can import sentence transformer. Let me execute it. I can have the sentence transformer. Now just paste the model. Okay, so this is my model. So my model is ready. So once that is ready, we can go and create a vector storage bucket. Okay, for that I can type create index. Okay, so this create index need few parameters. One is it required the bucket name, vector bucket name can be given here, and I need to pass my index. Okay, so index name, I can say my index name will be test444 will be my index name, very bad name, but I am giving that, and I need to mention the dimension. So dimension will be 384. Okay, 384. Let's have a data type now. Data type will be float. 32 we will be using. Now I can measure distance matrix. Distance metric will be cosine. Okay, now I need to have my vector bucket name. For that I can get it from where I will get, I think it's YouTube1. Let me check this. Okay, it's YouTube1, so that is my name. So let me go and give YouTube1 here. YouTube1. I am executing. So the execution is progress. We are successfully created the index now. Okay, to see that, let's go and check my bucket. It's loading. We can see that our index is created successfully. Okay, now create some dummy sentences. I am here. I am going to create some dummy sentences. Sentences will be, I can give some movie names like Star Wars. I can give Jurassic Park, and also I can give Finding Nemo is another one. Okay, so these are the sentence, and I am going to embed this sentence. So I can create the embeddings. Okay, for that I can use model.encode. Just pass the sentences here. So the execution is progress. This is done successfully. Okay, so one thing that we need to remember, just check the type of the embeddings. So just check one embedding. So its type is ND array. Okay, so here if you look on this, we have specifically said it is float 32, right? So we need to convert these embeddings into the float 32 type. Okay, so that we can do. Now let's import NumPy. For that we can use the NumPy for that, NumPy as NP. Okay, so we have ready with our models and embeddings and everything. Now we can import this into, or we can insert this into our index. For that I can use client dot put vector. Okay, for that I need to loop through each embedding. I can use for I sentence in enumerate sentences. So let's take first embedding. Embedding will be, I can take the first embedding. So this is the first embedding. We need to convert this embedding to float, right? I can use a simple if statement. I can check if is instance of embedding comma np.nd array. So if it is not, I can send the embedding, otherwise I can convert the embedding to the float. For that, simply I can use embedding dot to list. Copy and paste it here. Okay, I am missing the else embedding. Okay. Now I can create client dot put vector. Let's give vector bucket name. This will be YouTube1. You can give the index name. Index name will be test444. Now one by one we can add the vectors. So vectors, let's create some array. Here I am going to specifically say about the key. Key will be a unique ID. I am going to give the sentence, but you can give any GUID here. Now let's set the data. So data will be first float 32. It will be embedding list. Embedding float, so that is the name. So let me have embedding float. The spelling is correct. Let me copy from here, paste. Okay. Now we can give the metadata. Let me give the metadata. I can set as a source underscore text. This will be sentence. Okay, executing. So the execution is in progress. Okay, so all the details are pushed to the vector store. Okay, now I can try to create some input text and we will try to query that. Okay, let's have the input text. I can pass the star was. Okay, this I am going to use. What I need to do, I need to make the input embedding first. Embedding, for that I can use model.encode. Model.encode, I can pass the input text. Okay, execute it. Execution success, and I need to change this into the input list, right? I can copy from here. Let's paste it here. This will be input embedding. We are converting to the float. Execution is progress. Now let's create a response. So my response will be, I can do client dot query vector. Let's pass these two parameters, that is my index name, and the bucket name. Let me do this, and let's do query vector. Class float 32. This will be my input list. Let's give input list, and I can return the top k is equal to 3 or 2, maybe 2 is fine, right? And I can say return distance value can be true. Okay, also I can return the metadata. Return metadata also can be set to true. Okay, so the coding part is done. Now execute it. So I got my response. Let's print the response here. So here we can see the vector details. The key is star was, and okay, so details are not clear here, so we can just dump this JSON. So let me do that second. So let's write import JSON. Print. We can dump this result. Okay, for that I can take the response. Here this will be vectors. Let me set some index is equal to 2. Print it. This will be indent again, same mistake, indent. Executing, again I am getting some error. Print json dot dumps response. It will be vectors, and I believe the comma has some issues. Let me do this. Okay, now we can see the result, right? So what I have given is, I have asked the star was, and here we can see some distance, right? Star was, its distance is like 0.00346, and here we can see the distance is also 0.03346. okay, somehow both are giving the same result. Let me see what is the problem here. Okay, so the embeddings are correct. YouTube 1, let me change this into star was. So I am trying to check like what is the issue there. Here I am giving star was, and this is my embedding, and I am converting this input embedding, and this is my input embedding dot list, and I am using the query vector will be YouTube 1 test for query vector, and I am getting the 3 return the distance, and the, if I put top k, let me see what will be the result. Okay, it is giving Jurassic Park. Okay, it's actually giving a wrong value here. So I believe there is some issue with our code. I will quickly try to debug this. Here we have the sentences here. Sentences, I am giving the sentences, I am giving the embedding, and this is embedding dot 0. Okay, so the problem is here we are always giving the same embedding. Okay, that is where we are getting the same result. So let me change this into maybe another one I. Now let me execute it. So here I am checking star was, again star was, again star was, executing. Okay, now we are not getting any result. Fine. What I will do, I will give top 3 maybe. Okay, so now if you look on this, we can see the star was is the shortest distance, and the Jurassic Park and the finding memo are giving the highest distance. Okay, so in this way we can easily do a similarity search with respect to the S3 vector storage. Okay, so in our coming videos we can discuss how this can be utilized in our LangChain, maybe RAG applications. Okay, so that is all about in this video. Please do like and subscribe. Have a nice day. Bye bye.